Cool. Welcome, everybody. It has been some time since we last met, and mainly due to my scheduling through the last six weeks. I know everyone's been hard at work, and you know we are nearing the end of summer. School is starting. Things are starting to become more normal, which is good. But after the pandemic, we just had a huge list of travel requirements, which was fun, but yeah, it made it tough to nail down schedules. So I appreciate you guys hanging tight. And this may be a big update, but I won't try to take any more time than I need. And also, please feel free to ask questions, because a lot of stuff has come about, and hopefully with this time, we want Tyler to show some of the architecture with HyperCloud, which is what we're calling our kind of cloud / portal project. And then maybe Trip can show some of the design, the UX design, and get some feedback there. And then, really tackle any questions as we go through. So with that, I'm going to kind of jump through the list. And again, feel free to interrupt me as things come up. Let me, here we go. So I've got this little roadmap, and it is August. One of the cool things in June, we made the decision to migrate to Dino. And we were just talking earlier that, even though Dino is still early days, some of the things or challenges that we're running into the node side, we don't have those challenges on Dino. Dino has linting built in, formatting built in, testing built in. So all of those are just non-decisions that we have to make, and super easy to implement in CI/CD. And yeah, I think overall we've been really pleased with Dino. It was, kudos to Tyler for really knocking out the core migration. And we've all been kind of working through the adapters. And, if, as we test them, as we move on this cloud project, it feels really solid. The adapters feel solid. Dino feels solid, at least from my point of view. Tyler, any comments or thoughts from the migration standpoint?
I'd second all of that. There was a bit of, I think the biggest challenges with Dino was some of the like native APIs in the node ecosystem, like in particular streams are handled differently in Dino. And then so that had to be reconciled. And then just finding like dependency matchups, like for certain adapters that use a client, we had to find something that we could a similar client on the Dino front, or kind of roll something of our own. But all in all, it's been a really pleasant experience, and Dino has been working great.
Cool. Trip, any comments from your side with Dino? Cool. Casey, I don't know if you played around with DynamoDB and Dino, but Tyler and I have gotten familiar with the AWS SDK with Dino, and it matches the documentation of the Node SDK pretty well. Like Tyler said,
is it the V2 or the V3 SDK?
We're using the V2, I think.
That's the one that DynamoDB one uses too.
Yeah.
You're saying some of the built-in Dino ones are different. Is the crypto API the same?
No, no. The crypto API is implementing the web crypto API. So it matches one for one, and it's just released. So I'm sure there's some warts, but they finally got asymmetric encryption in the crypto API, but it is one for one with the web crypto API.
Okay. I think so for the DynamoDB adapter, then it's possible that or at least the version of it now, I know that Tom, you talked about a different one. When it's doing the crypto hashing to get the ID, it would probably require a different function.
Probably.
I'm assuming the web crypto does cryptographic hash functions.
Yes. Yep.
Okay.
Yeah. Yeah. The hashing's pretty solid, and like they just added kind of the asymmetric encryption where you can generate public private keys for different crypto algorithms, and sign and verify all those things. But I haven't played around with it yet. I was very excited to see it released, and it's cited that it's following the web API. I really like Dino's move there because MDN has great documentation on that, and it's nice to be able to go to MDN and get documentation on things like that. And they work in Dino out of the box. So that's really the Dino migration. As we started to design, and we went through a pretty good design process with hypercloud dashboard. We decided to start with AWS as our cloud vendor, and we matched all of our adapters to AWS services. So we attached S3 for the storage service, SQS for the queue service, and we created a document DB MongoDB adapter. It was kind of interesting. Document DB is a MongoDB API compliant service, but then there's MongoDB Atlas service, and we're building to MongoDB, and so far document DB is holding up. But if we do run into any challenges, we are prepared to move to Mongo Atlas. But so far, other than a couple of headaches for Tyler, I think we've done okay. Do you agree, Tyler? Yeah. And then
so.
Elasticsearch for our search adapter, and Elastic Cache, the Redis version, for our cache adapter. So that's pretty cool. That's all in place, and Tyler has built an awesome infrastructure as code set up. I'll let him talk about that in a little bit to deploy that in a scalable way. It's incredible. And then the other thing, one of our customers, CityBot, uses Hyper and also has this need for crawling documents. And we created a new port called a crawler, which basically is an API to allow you to crawl websites. And with that API, there's an adapter that I called Spider that actually does the job. So basically you say, find me all the pages for hyper.io. And then within each one of those pages, it creates a tree of all the pages based on a depth level. So this recursive tree, which kind of falls into an array. And then for each one of those pages, it actually uses a tool called Puppeteer that runs a browser, and you can actually execute JavaScript on each one of those pages to pluck data from it, hence the spider process. And I don't know how many people will be excited about that, but I was really glad to see that come around, especially for CityBot, who works with government sites and extracts information to create a search engine so that you can, text and say, when's recycle day? Or please come pick up this trash, stuff like that via text, which is really cool. But anyway, that's a new port. Went through the process all in Dino land, and it wasn't too bad. There was a couple of places where I forgot about on the core to hit, and the good thing is our test framework kind of directed me to those places where the missing bits were, which is a good sign, that we've got some good kind of unit/integration test in there that's very kind of focused. So need to work through that and document that, because I've published a couple of RFCs to request some more ports in the future. And Casey and I are talking about maybe some ways to write design documents for ports and adapters that we can kind of contract out or kind of put a bounty on, which would be cool. So those are the items that I have. I think we're still pretty on target with our roadmap. We are knee deep in the development of the cloud product, and I'll let Tyler talk about the architecture and then pass it over to Trip, talk about the front end documentation. Tyler did a great job on the contributors guide, and Trip also did a great job kind of reformatting that. I finally got around to adding documentation to the storage API. So we've got that documented, at least started. And I'm giving a API workshop tomorrow, really focused on kind of a starter's guide API 3-hour workshop, but hopefully that goes well. And yeah, that's it for me. I'll pass it over to Tyler to talk a little bit about the hypercloud architecture and how we've kind of really made this product to be able to scale as automated as possible.
Thanks, Tom. So I can go ahead and share my screen. Can everyone see this markdown document here? Cool. Yep. So as Tom said, I'm going to talk a little bit about some of the architecture decisions we've made so far with HyperCloud. So we had a couple goals in mind going into this that are, some of them are outlined here. I'll just gloss over them really quickly. We wanted something that, given that we're a team of 3, we don't want to be messing with our infrastructure. We don't want to be messing around with DevOps a whole lot. We'd like something that we're able to sort of set up and kind of depend on to run to do things like provision our infrastructure or like promote through environments, things like that. So the less sort of DevOps stuff at this stage, the better for us. We wanted something that was, so we wanted to minimize sort of the API surface that we were going to have to deal with. In other words, we didn't want to have like a million tools that we're having to juggle or to get spun up. Ideally, the less tools that we have to use, the better. We wanted everything to be containerized, which is to say Docker. We wanted to be able to basically spin up images and deploy those. And as Tom said before, we're using AWS. And so anywhere that we can sort of leverage AWS or tools built to deploy things, provision things on AWS and deploy things on the AWS, the better. So we looked at a couple different options. Of course, there's all these infrastructure as code tools out there like Terraform or Pulumi or CloudFormation. We wanted something that was a little bit more hands-off than those, and we did some digging, and where we ended up on was a tool called AWS Copilot. So Copilot it's a CLI that's built on top of ECS, which is the Elastic Container Service, and AWS, and it does a lot of things out of the box. It basically gives you a CLI for building applications on ECS with sensible defaults, and has a way to push those, provision that infrastructure, push environments, and then promote through those environments all through the CLI. So it's pretty great. So we ended up going with AWS Copilot and deploying all of our stuff on ECS, and then using Fargate for our container fleet, I guess I would call it. But that leaves that's for all of our backend services. And then for our front end, we ended up settling on, of course, we want to use AWS. So we were like S3 and CloudFront, but the less we have to deal with that stuff directly, the better. And so what we ended up going with was a tool called Architect, which is a tool that Tom is familiar with and he's used and likes it a lot. Basically, it just is another CLI that we can use to build out our application. It can be used to build out just Lambda-based applications all behind API Gateway. We're using it in particular to build out our front end that's built on top of SvelteKit, which supports static content and then as well as Lambdas. So if you're familiar in the React world, like with Next.js, it has like sort of like the route sort of folder-based structure where you can just have a file in a folder and that gets transformed into a Lambda. So Architect supports that same sort of thing. So those are the tools that we sort of settled on. And then it was a matter of deciding, okay, what were we going to deploy? We went through a couple and how and what was that going to look like deployed. So we went through a couple different iterations of this. Since we're using Copilot, we're building on top a lot of the things that Copilot provides. So Copilot has the notion of like a publicly exposed web service, which Copilot sets up the ALB. It deploys the containers into public subnets across availability zones for us. And then it hooks into service discovery. So AWS Cloud Map so our services can talk to each other within the VPC. And then the backend, and then Copilot defines like a backend service, which is basically the same thing. It's just not exposed on the public internet. So it's not hooked into an ALB. But they can still use service discovery to talk to each other and whatnot. And this is all deployed in a VPC and on ECS. So we went through a couple different approaches. I won't go through each of them on what would be the deployables. Where we ended up, we went through like, okay, just containerized everything. We ended up getting something close to this, which was having Architect for our front end and then having instances of Hyper for the dashboard, and then an instance of Hyper for the cloud endpoint, which is where all the consumers of the dashboard, when they set up their apps on cloud.hyper, they would hit this endpoint to consume their services. But then after a conversation with Tom, what we decided on is that we should just do the ultimate dog food and just use cloud.hyper itself to build out the dashboard. So there's sort of a chicken and the egg sort of dynamic there. But we've figured out how we're going to do that, and where we ended up ultimately was this sort of layout where we have our architect app, which is basically our SvelteKit app, and then those SvelteKit lambdas will itself consume cloud.hyper.io for all of the data specific to the dashboard, and that'll flow through API gateway, which will be authorized by a Lambda, and then that'll flow into our ECS cluster and into our Hyper instance. And so we're going to be a consumer of cloud.hyper.io just to build out our dashboard, just as anyone else using the dashboard to build out their apps. So this is sort of what we settled on. And again, all of this is automated through Copilot, and Copilot provides a way to, for any of those ECS services, it has the concept of add-ons. So we have all of the managed services that we're hooking into Hyper, like Elasticsearch and DocumentDB. All of those, we have set up add-ons inside of Copilot, which is effectively little bits of CloudFormation. And Copilot takes care of aggregating all of that together and deploying that as a stack inside of Cloud, as a nested stack inside of CloudFormation. It handles things like permissions and attaching managed policies to our ECS task roles for security. So everything's bundled up in Copilot, and this makes our CI really easy, because then any any code that's merged can just be deployed all using Copilot and no additional tooling. So it's really nice. We already have all of our code being deployed by GitHub workflows, and that's working really well. Let's see here. Anything that I missed? I think that's basically it at a very high level. Is there any questions?
Are you giving yourselves a good price for using HyperCloud?
Yeah,
we get the ultimate discount.
the employee discount. Yeah, and both Dash and Cloud are scaled automatically. So Architect works on Lambda, and it scales through AWS serverless, and then Fargate and the container service has automated scaling metrics on that. And I think you set all those up through Copilot and CloudFormation, right, Tyler?
Correct. Yeah, that's a good thing to highlight. So everything is set up with auto scaling policies. As you said, with Architect, it's just serverless, just scales to the moon. And then with ECS, we have scaling policies based on CPU utilization that gets set up on the ECS task definition. So if traffic to a ECS service deployed on ECS, the CPU hits a certain amount, it'll automatically auto scale out and then auto scale back down when traffic dies down. And that's all set up through Copilot as well.
And I think one key point, which, give Tyler a lot of props, because this was a super hard problem to solve. But with this architecture, there is a clean, loose coupling between what is AWS Copilot and AWS infrastructure and what is hypercore, so that we can continue to develop hypercore completely open source, and the boundary between that and what is cloud hyper is very well defined, so that we will not bump heads. And one of the challenges was the API and multi-tenant, and being able to essentially add an extra kind of namespace in the API without the hypercore having to change, which was pretty awesome.
Yeah, thanks, Tom. I think that's it at a high level. Of course, if anyone has any questions or wants more details, feel free to reach out on Slack. But I think that's all I got.
Cool. Thanks, Tyler. All right, Trip. You want to show us some cool candy?
Yeah, let's look at some eye candy. Can you guys hear me okay?
Yep.
Can you guys see this screen okay? It says Hyper Developer Dashboard.
Yep.
Excellent. Well, then we'll get started. So took some screenshots of the new Hyper Developer Dashboard that's currently in progress, in flight. Tyler and I have been working on this. Been mainly focused on the UI and requirements for it. So let's walk through some of the pages. So this is first is sign in, sign up. So right now a user can sign in using their GitHub account. So that's what that looks like. It's pretty exciting. After you sign in, you'll see your applications for your user account. So up in the upper right-hand corner, you'll see my lovely avatar with my username from GitHub there, as well as related hyper applications. So a hyper app is a concept where we organize hyper services underneath. Each application, as you'll see, will have keys to access it from a server to server communication to your app. So let's keep going just a little bit. So with the menu on the upper right hand corner, you could switch from your personal account to a team. So apps can be organized under your own personal account or a team, and you can add as many teams as you'd like. Well, there may be a limit on teams. My memory fails me, but once you switch over to a team, the avatar will change. You'll see your link to your relationship and your link back to your user account here within the avatar for your account, and then your applications will be displayed for that team. You'll have the ability to see what level you are on, whether if you're on a paid level or a free level. So in this example, it's a free level, and that they have, as you know, 3 applications. And right now they're at their limit. They've used all of their hyper apps in this case. So they have the opportunity to prompt to go to a paid account if they wish. Yeah, so you're at the free level and you can go to a paid account. If in this case we have a team account that's at the paid level, it's a paid account at the startup level. So we'll have different tiers of paid accounts. And in this case, since it is a paid account, you'll get 10 hyper apps, and they've used 3 of those apps so far. So it's 3 of 10. You could purchase more apps, or you could, add a new application. So when you select an app, you click one of the tiles and you'll select an app. And once you've selected app, you'll see several tabs: keys, data, search, storage, cache, and queue. The default will land on the keys. These are your app keys to be able to connect to your Hyper app, which will give you access to the services related to that Hyper app. So here you can see your keys, key and secret. You can add an app key to your list. So you can add different, you have one of many app keys for a specific Hyper app. You can also display the secret. You guys have probably seen that functionality before. So when you click the eyeball icon, you see the secret here, and you see the connection string that you can use with the Hyper client to easily connect to that specific Hyper app. And you also get a clipboard button to copy and paste these keys, secrets, and connection strings as you may need them for your client application that wants to talk to Hyper. You could take a key and you could temporarily disable it if you don't want an app using those key pairs, or you could delete the app key altogether to prevent a client from using your Hyper app and the services beneath it. So that's just a quick sneak peek of where we are with the developer portal. Tyler and I are currently working on schemas for communicating with GraphQL. And GraphQL will then turn around and talk to Hyper, since we're using Hyper to build Hyper. We're dog fooding our own stuff, drinking our own champagne, right? So that's kind of where we are. Hopefully there's no questions. If there are, that's cool. But any questions at this point? Cool.
Looks easy to use.
Mm-hmm.
Oh, that's good.
Yeah, and I think one comment, no questions, but one comment is that and I just lost it. Yeah, I lost it. Sorry.
Was it about an app key or dog feeding Hyper? Or about how awesome Tyler is?
Oh,
See, I knew that would prompt you.
it was related to Tyler. No. So Tyler is working with building a GraphQL API for the dashboard to talk to the dashboard business logic, which is really cool. But that kind of triggered the fact that when we did the Dino migration, Tyler included not only the REST API, but the GraphQL API in the Hyper migration. So out of the gate, when you create a new app, you will have an option to either use the REST API or the GraphQL API with no changes. So I thought that was really worth mentioning.
Very cool.
GraphQL.
Yeah, I'm just trying to put a pretty candy wrapper on this awesome stuff that Tom and Tyler and Casey have built. So,
And it looks really good, Trip. It looks really, really good. It's a great start.
That looks great.
Cool. Thanks for demoing that. Again, great work. Trip started back in May and Tyler started in June full time, and just over the moon with the progress that we've made. Pretty awesome. And Casey did contribute to the DynamoDB adapter. We're still working on finishing that, but he passed it over and super good shape for us to potentially create kind of a free tier, possibly with DynamoDB. I don't know. That's just some thinking. And the other, I guess the only other thing that I had was, Casey and I are talking about, kind of creating contracts for hyper adapters and potentially plugins. We talked a little bit about plugins, and Tyler and I have been talking about plugins, but we think that over the next few months, we'll be able to really provide some solid insight on plugins. Tyler's experimenting with a couple of ideas for plugins right now. And with a plugin, basically, you'll be able to add logic that can sit in front of the adapter. So it doesn't really matter what the adapter is, but this plugin can do a very common piece of functionality for that adapter and possibly talk amongst the services to react to either events from the service or send requests to those services. Did I describe that okay, Tyler?
Yeah, that sounds right, Tom. And I think plugins are really, they're just built on, they're just composed on top of the adapter definition. So it can do things like change what goes into the adapter. It can change what's coming out of the adapter and returning back to the core layer. So just experimenting with it right now and dogfooding it to see if it's a good pattern. And so far it's working out pretty well.
Awesome. Well, I think we covered everything I wanted to cover. Is there any questions or comments at this point? Awesome. Well, thanks again for everyone's time, and we're going to keep cranking. We're really shooting for October to have something usable, but as you know, we're in the early stages, so we'll see how that goes. And probably I think I'm gonna shift these meetings to monthly, because I don't think we'll have much more to show except every 4 weeks. And yeah, looking forward to the next meeting. And as you know, we're always available, so if any questions pop up, and if you want to sit down and go through a demo, happy to do that. Just reach out. And thanks, Trip, Tyler, Casey, thanks for all of your work, and looking forward to seeing this start to really get out the door. So super excited.
Thanks, Tom.
Absolutely. And it goes without saying, but thanks to Tom for, he's built out a couple of adapters and then just has beefed up the documentation. And then as far as getting all this AWS stuff set up, we know that I'm sure we all have gotten a little bit of a taste of AWS and how much of a beast it can be. But Tom was able to set me up with everything that I needed to get Copilot set up. So shout out to Tom for getting all of that when I needed it.
Yeah, no, that's I'm glad that is working out, and kind of keeping things at this point in the game kind of simple, because you're right, AWS is a beast and it can get complex pretty quickly.
Yay, Copilot.
Yay, Copilot. All right, guys, well, have a great afternoon. And we're doing a Charleston JS meetup August 26th, please tell your friends. It'll be in person at the Charleston Tech Center. So please let everybody know. I think that'll be a cool, get together face to face and hang out. So looking forward to it.
Cool.
See you guys.
See you.
See everyone.